Okay, so if you see in the previous session, we have but I have told you that there will be some database action and there will be some violations that will be done. Okay, so what happens, what are the actions that will be taken care when we are performing some kind of a constraint violation? Okay, so what to do in these particular cases? Okay, so now in the insert part I have shown you four different kinds of violation that is on domain constraint, another one is on key constraint, another one is on integrity constraint, entity constraint, and last one is for the referential constraint. Okay, so I'll show you one by one that how can you do a violation. Okay, so what is the action that is taken? So action was that the database system is designed in such a way that we reject all these things. Okay, so if I want to violate it, the database will directly show you an error without anything. Okay, so you cannot do anything, it will directly show you an error. Okay, but where things gets interesting is in the way when we are converting, when we are deleting. Okay, so suppose in the similar format the same table, employee table, is given to you. Okay, so suppose e number, name, and then there is a d number. Okay, so how can you violate these particular constraint? That is domain constraint, key constraint, entity integrity constraint, and your referential constraint. Okay, so if you delete the value in any column, suppose I want to delete the value in e number, and then what is the corresponding name and what is the department number. Okay, so if I delete it, it will not affect any domain constraint. Okay, so by deletion domain constraint will not be affected. Okay, so I'll say there will be no violation if I delete anything. Okay, similarly if the key constraint was that if you want to enter anything new. Okay, so if I delete any key, if you delete any key attribute, if I delete any value in the key attribute, again the domain constraint will not be affected. By deletion there it is impossible to cause any kind of a violation. Okay, so what is entity integrity constraint? That should enter a null value. Okay, again by deleting anything, again there cannot be a violation in this particular case. Okay, so by deletion there is no violation in these three particular constraint, but referential. Okay, now see here, I'll take an example here. Suppose okay, suppose what I'll do, there are three departments, so 1, 2, 3. So three departments, suppose is mechanical, and then there is a fourth department is civil. Suppose it's like this. Okay, so ECE, CSE. Now you see here what I'll do. If I just wait a second. Now the violation, how the violation will be caused if I do something. Okay, so if I delete, now you already know what is a foreign key and what it actually it's referring to. Okay, now there are two ways that we can solve any kind of a problem. Suppose what I'll do, I'll delete this particular entry, this one. Okay, so it is already referring to this department number table, and if I delete this particular entry, that is 3 mechanical engineering. Now what will happen to this entry? Okay, so what will happen to this entry if I delete this entry? What will happen to this entry? So now this is the referential constraint that is caused. Okay, so I'm saying how can you cause a referential violation? You just delete 3 from department table. Okay, so when this particular thing occurs, the referential integrity constraint is violated. Why? Because there is an entry 3 which is not contained in the referred table. Okay, so the foreign key is referring to this table, and there is no entry 3. There is no entry related to 3. Okay, that causes some problems. Okay, so now how to deal with it? There are two ways to delete. There are three ways to deal with it. First is very simple, that you should not delete, that you should reject this particular operation. But in most cases it is not possible. So you have to, so suppose you are if you are opening any kind of a business. In a business, a particular department is not performing well, so due to some budget cut you have to close that department. Okay, so now it is upon you that either you directly want to close all the department with its employee. Okay, so if you want to close the department and you want to fire the employees that are related to the department, you should be able to do it. And if you want to just what you said, close the department, but you do not want to fire all the employees, you want to assign those employees to different particular departments. Suppose, because if you see here now, suppose in nowadays the Indian Post service is very rarely used. Okay, so what they do is they assign those particular people to different departments. Okay, so they not be specifically related to what you say, postal service, but they may be related to another things that is related to postal service. Okay, so in the similar way, I think if you are closing a department, it does not necessarily mean that you are firing all the employees. You may want those employees to work in other departments, so that can be possible. Okay, so there are two scenarios. First scenarios is that you are closing the department fully and you are firing all the employees. Second will be that you do not want to fire all the employees, you just want to assign them to a different department. Okay, so again there are two options here that you can do that. That first one is cascade. Cascade means that if you delete from the main table, if you delete a department from the main table, everything will be deleted to other tables also. Okay, so if you are deleting a department from the main table, the refer table, uh, deletion and it will automatically delete it from the other tables. Okay, so this is your cascade option. Now the third option is your set null option. Okay, so it is used in that particular case when you do not want to delete all employees. You want to uh, keep the employees, that so that you can further in coming week or in a coming year you may assign different particular departments. Okay, set null means you just the referred employees will be set to null. Okay. So it is as simple as that. So what is the meaning of it? I'll give you example. So suppose this same example I give you. So suppose in employee number name D number D. Okay. So suppose you have deleted the entry of 1 CSC, 2 CE is remaining. Now what will happen? All those employees who are associated to the employee to the department 1 here will also be deleted. Okay, so if you want to close the department fully, these employees, if you delete this one will automatically be deleted. This is called cascade delete. Okay, so if you are deleting from the main particularly what you say main table, the refer table employees whole columns, whole rows will be deleted. Okay, so if you are wherever there is a one, you can delete the whole row. Okay, another option is that you do not want to delete it, you can directly set another option will be the same thing. This is referred to as a cascade null. And other option will be rather than deleting it, you are just setting the department number to be null, okay, rather than whole deleting. but it means that you do not want to fire or remove all the database of the employees. You just want to give it to null. Okay, so you just want to assign the id null, so that in the later coming days you can assign everyone in a different department based on their capability. Okay, so that is how your this particular thing is referred to as on delete set null. Okay, so these are particularly two options that is available till here if anybody has it. Okay, so now modify is a combination of insert and delete. So you already know that I have shown you insert and delete, so it is based on the same thing. Okay, so it is a combination of this. You can check it out that particularly what constraint will be affected, and you can perform everything based on that. So mainly there were only main two constraints, that was what happens when there is an insertion and insertion cause violation, and what happens when there is a deletion and deletion cause violation. Now moving on to your main topic that we were studying for the last week. Okay, so we are preparing for the last week for the topic that is your conversion topic. Okay, so it is now we are here where you have to convert er to relational model. Okay, so my main motive before before going into this particular model was to show you how actually foreign key works. Okay, so I in this particular example, that is why I've included more and more examples of foreign key. Okay, because I will be using foreign keys here when there are relations, because how can you show a relation in tables with the help of a foreign key? Because foreign key can be, what you say, it is forming a relation outside of the table. That is why I've shown you many examples of foreign key. Keep that thing in mind, that how particular foreign key works. Okay, it is different than your primary key, and foreign key can be more than one in a table, and you can enter null value in a foreign key. So that is why I have shown you that on delete set null part. Okay, now see here, again there is a algorithm that is related to it. So again I will share the ppt with you. So the ppt is already there, let me check. Okay, so ppt is all will already be shared with you. So I'll be using different example with this one so that you can easily understand it. Okay, so there are more examples given in the ppt. So I'll again one and the same thing. Okay, so everything that I'm teaching here is already available in the P2P. Okay, so there may be some extra point and there may be some extra example that I'm teaching you here. Just keep that in mind. Okay, so the step one, I'll go step by step. So the step one is again it's kind of an algorithm to convert a ER diagram into a relational model. Okay, so first one is to just directly convert entity into relation. Entity into relation. You already know what is a relation. Relation is actually a table. Okay, so suppose this is the this is the diagram that is given to you. So you have a student entity, and with the student there are so many things that is related to it. That will be something called student number, or I'll say roll number rather than student number. I'll say roll number, then student name, and then student name can also be divided into two parts, that is first name, last name. Just wait a second. Just wait a second. Okay. So this is referred to as your composite attribute because there are more than one particular attribute that is related to it. So the name can be again divided into, student name can be divided into first name and your last name. Okay. Another thing was your marks, and you can also add a multi-valued attribute that will be your phone number. Okay. So I'll tell you about the phone number part. How can you do it? So it will be in the relation part. I'll show you. Okay, so in the relationship type part, so just wait for it for some time. Okay, so the conversion is very simple. So student entity means the name of the table is student, table name is student. Now you will be directly converting. So how can you convert it? So in case of simple attributes like a roll number, you can directly write roll number here. Marks, you can easily write marks here. Other is name, student name. Okay, so student name you cannot do it like that, so this is a composite attribute. So how can you write student name? Student name can be written as f name, first name, and last name. Okay, so you cannot write student name as a whole attribute because it is a composite attribute. So whatever the parts of the composite attribute, you have to write it. Okay, so that is first step. So we have only done one complex thing, that is how to write composite attribute. So you cannot write composite attribute like student name. You have to write the parts of the composite attribute, that is first name and last name. Okay, so the remaining part only is your phone number, because phone number is a multi-valued attribute. It means it may have multiple, you people may have multiple phone numbers. Okay, so that you already know that there cannot be multiple entries allowed in the table. So multiple entries cannot be allowed in the table. That we have already studied in the domain constraint. Okay, so you cannot put here a phone number and you say that there are two phone number entries for that one. Okay, so I cannot put it. Okay, so I'll show you that how can you deal with multi-valued attribute when I come to end-to-M relationship, because in both of the cases there will be a multi-valued attribute, because a particular employee is working on multiple projects and a project can have multiple employees. Okay, so in both of the cases this they may have a multi-valued attribute. Okay, again I'll show you example of it, don't worry about that part. Okay, so you do not include multi-valued attribute right now, so I'll tell you how to include it. Just wait for some time. Okay, so just wait for some time how to crack this multi-value. I'll show you in the next one. Now this is very simple. Okay, so table conversion, you can already see that roll number, first name, last name. So only thing was this composite attribute, and then there is marks. It's very simple to convert it, and everybody can easily convert it. Okay, so now I have to show you different scenarios here. Scenario second will be, so step second can be, there will be weak entities in that relation also. Okay, so you already know, if I take the same example, employee as dependents, there is an identifying relationship and there is a total participation from the employee side, from the dependent side. We have already done this relationship. Okay, so there is something called a name and age and relation. There is e number, now there is e name. Okay, so now if you're seeing here, this is your strong entity because it has a primary key. This is your weak entity, it does not have a primary key. I'm writing it here, quoted, what you say, dotted line here. So this dotted line name is referred to as a partial key. Okay, so because nobody is acting as a key independent, so for a part of a table, name can act as a key, but it is not a total key, because in key the name should be unique, but name cannot be unique. A name can be repeated anyway. So I'm saying that name here is a partial key rather than the full key. It is a partial key. It will serve some purpose, but it will not serve the full purpose of a uh, that of the key attribute that you already know. Okay, so partial key is like it is acting as a it will be acting as what you say uniqueness for a part of the table. It cannot act the name cannot act as a key attribute for the whole table, because name can be repeated, but that is why it is referred to as a partial key. Partial key means that for a part of the table, this name can act as a what do you say, a key attribute. So suppose if you're not talking about the whole employee data set, but only for 10 or 20 employees, in 10 or 20 employees you can say that name can be unique. Again, I'm not sure. Again, in 10 or 20 employees, the name can be repeated. So that is why it is not referred to as a primary key, it is a partial key. Okay, so what is a partial key? That partial key can be unique. That key attribute is serving as a key attribute because there is no key attribute in the weak entity. Okay, so how to convert strong entity into a strong entity and weak entity into tables? Now there is a relationship now. Okay, so previously there was no relationship, previously there was no relationship, only there was one entity with its attribute. Okay, so if you already know, the attribute will be the columns of the table. So I have already explained you in the terminology part. This is attribute, this is attribute, this is a what you say, composite attribute. I will take this part of it. Okay, now here is a relationship. So this is a relationship, this is referred to as identifying relationship. You already know this. Okay, so employee has dependent. So I have to show a relationship in a table. How can I show it? Okay, so first of all, make the table for employee. So employee table can be very easy. That e number, e name can easily serve the purpose. For dependent table can be what is it? Name, age, then relation. Okay, so now I have told you how this is a weak attribute. So what can you do here? Okay, so I have to add a primary key to this particular weak attribute. Okay, so this is a weak attribute. So because there is identifying relationship between this, it means that the primary key of the strong attribute is also transferred to this weak attribute. So what it means is that you have to add e number here. Okay, so now e number will be referred to as a primary key. Sorry, e number, the main table is this one. So e number will be referred to as a primary key to this table. Okay, so now e number here is your foreign key. It is referring to a primary key, e number. Okay, so e number in dependent table is a foreign key which is referring to a primary key in employee table. Okay, so it means that we are relating primary key of strong entity set to the weak entity set by something called a relationship, identifying relationship. So identifying relationship is shown by foreign key. Okay, so most of the time the relationship part will always be shown by your foreign key. Okay, so keep that in mind. uh, Foreign key is used to show the relation. Because you already know that how can you relate anything to a table, outside table. So only there is a functionality of foreign key that can relate outside of the table. Okay, so that is why in most of the in every time, I will not say most, in every case, if there is a relationship between two particular entities, there always will be a foreign key. Okay, so foreign key is only the way that you can show a relationship between two tables. Okay, foreign key is used to show the relationship between two tables. Keep that thing in mind, it's very important part. Okay, so again, now the identifying relationship was on shown by the foreign key. Another thing is that because I say foreign key is dependent on the weak entity is dependent on the strong entity set, that is your e number. So if I delete any employee, okay, so due to foreign key, you already know property of foreign key. Okay, so due to foreign key, if I delete any employee, from emp table is your referred table, then its dependent should also be deleted. Okay, so this particular property is referred to as Cascade Delete. Okay, so we are deleting anything from the M table because it is related to this one. So everything that is that will be the dependent, that are those people that are depending on uh, the employee will be deleted. So here primary key is emp number. Here primary key cannot be emp number because on one employee there may be two people depending on it. So name, suppose Ram, there is an employee Ram, on it another person's like Sham with age 22 and relation is brother. Depending on it, again there is another okay. So there is another person that is what do you say, uh, his wife. Okay, so I can say that what is that? Okay, Raman is also depending on Ram. Okay, so if you're seeing here, there is an entry. The entry is 1 1. Okay, so entry is 1 1 here. So you cannot say emp number will be a primary key in this table. So the primary key will be a combination of the partial key with the primary key of the strong entry, strong attribute. Okay, so primary key here will be e number plus name. Keep that in mind. Here the primary key, I am writing it because it's very important to understand. The primary key in emp table is emp number. The primary key in dependent table is e number plus name. Okay, so e number plus name will always be a unique combination. Okay, so e number means that if I have a employee number of 22 and the name will always be separate. Okay, so there may be most of the time the name will always be separate. Okay, so e number plus name will always be a unique combination. Okay, any doubt till here? Okay, so
Sir,
yes, yes.
sir, employee number is always unique. So, like, why are there two different employee numbers for the given name? I don't understand.
So again, I'm saying that suppose you are an employee, so there are dependents on you. Okay, so you already know that there are some employee that are depending on you. So suppose I'm an employee, my employee number is 1. So my wife is dependent on me. So I'll say my wife, and the age suppose 30, and relation will be my wife, and another person will be my mother and father. Suppose my mother is also dependent on me and my father is also dependent on me. Okay, so we are seeing here the entries to this particular thing. uh, Entries in emp number part is 1 1 1, because why it is 1 1 1, because it is the employee number of me. Okay, so if that is why I have associated with it. But if you see the combination of employee number plus name, it is acting as a unique, because 1a is not equal to 1b and 1b is not equal to 1c. Okay, that is why there is a multiple entries here. So we already know that the primary key attribute should always be unique. Okay, so if there is one entry, this particular entry cannot be repeated. If I set only emp number as primary key, the one cannot be repeated. So here the one is repeating here, so that is why I have to set two primary keys here. So the combination of two keys, so that is referred to as a composite key. Okay, you get my point, or there is any doubt?
Okay, sir. Yes, I see.
So keep that in mind. So that is why it's a little bit confusing. That is why I've written this example. So one more thing, that one thing that there is one takeaway from this particular question is that foreign key is always be used to show the relationship between two tables. Okay, so if there is an entity which has a relationship with the other entity, you have to use foreign key to show the relation. There is no other way. There is no other way. Okay, so keep that in mind. Another thing is that foreign key has the two particular things, that is set null and set delete. Okay, so if you delete anything from the main table on which a particular entity is referring to, so if you delete that particular, suppose if I delete the employee from this table, so all the entries that is related to this employee should also be deleted. Suppose I left the job so that people that are depending on me on the dependent table should also be deleted. So they will delete my entry and automatically the dependents will also be deleted. So that is two takeaway from this. Okay, so now you need now kind of know that how there, if there is a relationship, how to represent the table. So I'll now move forward with relationship part. So you already know that one to one, one to n. So there are different ways to show it. So there are various concepts that are related to it. So I'll uncover on the concept one by one. Convert a relationship. So again, there in every example there will be a use of a foreign key. So that is why I've shown you in the previous lecture how to use a foreign key. So it will be easier for you to understand it. Okay. So I will be using the same example that is already being used. That will be employee manages department. Okay, so we have already done it when I've shown you the relationships type of relationship in an ER model. So this thing we have already done. So this is a one-to-one relationship where we have said that employee manages a department. So requirement part is only one employee can manage the department. The requirement part was one employee can manage the department, one department, and another was every department has to be managed by one. So it is already covered. Every department has to be managed by one employee. Okay, so this is already given to you. So based on that we have formed this relationship. Okay, so now one more thing that you have to know, that where is the total participation and where is the partial participation. Okay, so again you already know that every department should have a manager, that is clear to us, but this is not a set of managers, this is a set of employees. Okay, so there may be some employees that are not managing a department. Okay, so suppose in a computer science department there are a set of employees. In a set of employees, there will be only 2 or 3 managers. There will not be more than 2 or 3 managers that will be managing the employee, that will be managing the department. Only 2 or 3. Okay. So from employee side, there may be some employees that are not involved in the relationship of managing. But from the department side, every department has to be managed by someone. Okay. If there is a computer science department, there will be one manager that will be related to it. There will be, if there is a mechanical department, there will be one manager that is related to it. So we already know that. Okay. So now the total participation will always be from the department side. So keep that in mind. So now again I'm writing this so that you do not confuse. An employee can manage one department, but it is not necessary that every employee has to manage. Every employee has to manage, because this is a set of the employee, this is not a set of managers. Okay, so now see here, now you have to convert this relationship into tables. Now see, there will be very interesting part here. Okay, so there are two ways to form this relationship. I'll show you both ways, and I'll also show you which one is best, but you can follow any way. Okay, so now see here, for employee table I have to make the entries. So again I am attaching the attributes employee number, employee name. Here I am attaching the entry department number, department name. Okay, so now how can you make the employee table? Very simple, you just go there and you write emp number, emp name. So this will be your employee table. Now what is the department table entries? Department table will be department number, department, as simple as that. Okay, so now I have to show the relationship between these two, that is manages. Okay, so now how can you represent the relationship? You already know foreign key. So there are two ways. Okay, so always the easier way to represent the relationship is, you already seen, I also write it, that you can include this is very important, you can include primary key of one table to another as a foreign key. Okay, primary key of one table to other as a foreign key. Okay, so if you've seen this statement is very important because in the previous relationship we have also done this. Okay, so in the previous relationship we have taken the primary key of one table and put it as a foreign key in the other table. Okay, similarly now there are two primary keys. E number is a primary key, department number is also a primary key. Okay, so there are two ways to do it. Either you can take this E number and put it inside this D number in the department table, or you can take the department number and you can put it here as a foreign key. Okay, so there are first way you can take E number, E name, and you can put D number here to show the relationship. Okay, so D number here, and this D number will be referring to the D number here. So this is a foreign key that is referring to the department table. This is the first way, and the second way will be you can take the E number part and put it here. Okay, so it will be referring to, so this E number will be referring to this particular table. Okay, so there are two ways. Okay, so now which is the better way? Okay, so again these two ways are fine, but we will always be preferring a better way. Okay, so now I'm saying depending on the diagram you are seeing here, that there may be some employees that are not participating in the relationship department, managing department, but from the department side the department will always be managed by some employee. The department, from department you're seeing here, there is a total participation. Okay, so you're seeing here, if I just get into a little bit of a deep part, so from the first way, okay, so from first way if you try to enter anything in the tables, okay, so if I see department number and then there is a D number and D. Okay, so suppose from the employee table, there may be some employee, that are not managing any department. Suppose there are only two departments here. First is CSC and then there is a mechanical department, only two departments, but the employee list is around 100. Okay, so the managing part will be only two particular employees can manage the department, and for, if you're seeing here, for this one the D number will be nothing. Because the two people are already managing the department, that is CSC and ME. Okay, so the remaining employees will not, if you are understanding it, the remaining employee will not manage it. Okay, because that we have already known that a particular department should be managed by only one employee. Okay, so if there are two departments, it will be managed by only two people, so there may be other employees as well. So if there are 100 employees, the 98 employees, there will be no entry in this one, so there will always be a null entry. Yeah, you're getting my point. So I'm not preferring this way. Why? Because there will be there are many null entries in this, so I do not want to include more null entries than I have. But if you see the second way, here, try to do some entries. Now you will see E number, E name, and then there is a D number, D name, and E number. Okay, so in the department part, if there is a department CSC, it will be managed by some employee which has a employee number 1. If there is an employee, if there is a D number 2 with a mechanical engineering, there may be some employee that is managing. We are seeing here the E number and E name part, it is not, what you say, there is no null entry that will be included in any table, because if a particular person is managing the department, it will be only written 1 here. If a particular person is managing mechanical department, here will be only written 2 here. So we do not need to include any more entry. We are seeing here, you are getting my point. You do not have to include any null entries. So here there is a null entry. No, I'm not saying it is a bad way, but it is a bad way. Okay, so I'm not saying it is what you call a very effective way. So you can use it, there is no compulsion against it, but I do not want to use the null entries. Okay, so that is why the second way is the way to go. Okay, so second way is the preferred way. I'm again writing preferred because I cannot call the first way as wrong. Okay, so you can do it, but it is not advised. Okay, so it is not advised because I think you are wasting more space here. So you are just writing null, null, null. You are adding one particular what you say, because there will be more entries in the employee part. So there may be 100 employees. You have to write around 98 nulls. Okay, but there may be only 2 or 3 departments. Only you have to write 1 and 2, and there will be no null entry. So which is more effective way? This is more effective. So second way is the way to go. Okay. So why it is preferred? You already. Okay, so till here, if anybody has any doubt, I'll give you another example also. So again, I add one more thing here in the table, that there is something, sometimes there is something called attributes that are not in any, that are not related to any entity. Okay, sometimes in some question we give the attribute like start date of a department to the relationship, on a relationship. So that can also be possible. Okay, so if this particular thing happens, so because it is the start date of the department, so try to shift this particular attribute towards the department side. Okay, because you cannot shift this to the employee side because this is start date of the department. Okay, so try to shift it towards. So the table, if there is a start date, how will the final relationship will be? So final relationship will be employee number, employee name, and then there will be department number, department name, and then there it is a result. And then there is a emp number, and in the end I am writing start date, because start date is a attribute that is related to the department. Okay, so that is I am shifting the start date towards the department side. So this particular, sometimes in question what they try to do to confuse people, what they just they assign a relationship, they assign an attribute to the relationship. So what you do, you just understand the particular attribute, that what particular side it belongs to. Okay, that is why I'm writing start date towards the department, because it is a start date of the department. Okay, so you always shift the start date of the department. Okay, so every department will only have one start date. Keep that in mind. Okay. So till here, if anybody has any doubt, I'll take another example. It's again very unique example. So this is only one-to-one relationship. I'll show all the relations. So I'm again taking one more example. Uh, okay, so I'm adding the requirement parts. One part. Every person uh, have a license. Okay, so this is already given to you. This is already given to you. So don't think otherwise. Every person have a license is already given to you. Okay? So now see here, this is a different I want to show you this example because it's very interesting. So this particular based on this example, a particular question was asked in gate, and it's very interesting question. I think it was a paper of ISRO, and it was a very interesting question. So again, these particular scenarios are not covered by book, so that is why I'm listing you here. So most of many scenarios, they are not covered by book. So sometimes you are facing some kind of a scenario in a exam as well, so you have to think of it logically. Okay, so you always have to think logically. That is why I'm showing you all scenarios. Okay, so now it's saying every person have a license. So it means that if there is a person in the person set, it is particularly holding a license. Okay, so it is already given to you. So don't think that this is a set of those person that under 18 under 18 people should be there as well. So don't think like that. So it is already given to you that every person should have a license. So only uh, every single person will have a single license. A person cannot have two licenses. And if there is a license card, it will again be holded by some person. Okay, so if you're seeing here one-to-one relationship, and there will be total participation from both the sides, because if there is a person, he is holding a license, and if there is a license card, it is holded by a person. Okay, So see here, there's a total participation from both of the sides, okay. So now see here, how can you make this? This is very interesting, okay. So again, I'm saying that some particular scenarios is not covered by book, so you have to keep your mind open for these kinds of scenario that you will always face. So license number is a strong attribute, what do you say, primary key, and person ID is again a what do you say, primary key. Okay. So now you see here, when there is a total participation from both of the sides, what you do, you again follow the same approach. So you will be thinking, I can write PID here and PName here and license number, and I will say license name. You can add many attributes, I do not need to worry about that. Okay, so license number and license name. Okay, so one thing that you may be thinking, that take the primary key from one table and add it to other. Okay, so you can use the previous method, there is no problem in that. Okay, so you can use the previous method that we have already done, it is fine. But there is another way to combine this. Okay, so see, it's very interesting. So you may be thinking, you take a previous method means you can take the license number here, take from here, and you can place it here. Either there will never be a, what do you say, null entry. Okay, so every person will have a license number, there will not be a null entry in this case, and every license will have a primary PID. So there again will not be a, what do you say, null entry in this case. Okay, so both, there will be two ways, both of the ways are preferred way. Okay, you can go in any other way. Okay, so I'll show you. So we are thinking PID and then P name, and you are including a license number here, that is fine, and you are adding license number and license city. Okay, so this is the first way, and then there is another way, that is second way. PID, P name, license number. Similarly, license number, license city, sorry, I have P, and then there is PID. This is the second. Okay, so if you are seeing here, both of the way are preferred way, because there will not be a null entry from both of the sides. Because if there is a person ID, if there is a person name A, he will always be holding a license. And in the similar way, if there is a license here, it will always be holded by a person. Okay, so there may not be any null entry, so you can include any of them. Okay, so just wait a second. Okay, so both of the ways are fine, and there will never be a null entry in both of the cases. Okay, so if there is a person, there will be holding a license, and if there is a license, a person will always be holding it. Okay, so there will not be a null entry. Now, what is another third way? Third way is a very interesting way, that you can directly combine the table. Okay, so the final table will be PID, P name, L number, and LCD. So why it is a interesting way to do it? Because both of the entities have a total participation from both of the sides. Okay, so we are saying in every person will have a license and every license will have a person. Okay, so if there is a total participation from both the sides, so you directly combine these two entities. Why there is no, because there will not be a null entry here or in the first way, or there will always not be a null entry in the second way. So it is better that you combine it. Why keep a separate table? Now it will be saving you some space also. Okay, so when you are combining it, there will not be a null entry. Okay, because every person will have a license and every license will have a person, so you directly combine the table, and this particular table will represent more information than you are keeping the table separately. Okay, so previously you cannot combine the table. If you're thinking that I can combine the E number, E name, D number, D name, why you are not able to combine the table? Suppose in this particular case, you may be thinking that I can directly combine the table here also. You may be thinking E number, I can combine E name, and then there is a D number, and I can combine D name. So you may be thinking like that. Now it is why it is not possible, because every employee may not have a D number. Okay, because employee 1 is not managing any department, so there will be a null entry here. Employee 2B is not managing any department, there will be null entry here. There will be so many null entries. If there are 100 employees, there will be 98. If there are only 2 departments and 100 employees, there will be 98 null entries in the D number and D name part. So this is a wastage of space that we are not that we do not encourage. Okay, but in this case, because there is a total participation from both of the sides, you can directly combine the table. That table can represent more information. Okay, so till here, if anybody has any doubt, let me know. Okay, so I'll cover the remaining relationship type in the next one. Okay, so I do not want to confuse you, just revise this particular part. If any doubt, let me know. Okay, so thank you for listening. You can move on to the